Okay, yeah, I'm going to just basically walk you through kind of the experience that Lee, my wife, and my dad actually, we bought this boat together, and kind of walk you through how we decided to switch to an electric motor from a gasoline motor, explain how much it costs, kind of what the process was like, where we found the solution, and how we got it all working. As well, at the end, I'll kind of round it out with some of our experiences racing our boat with the electric motor and also doing a cruise out around Lake Ontario. So to start with, I guess a couple of years ago, and starting about 3 or 4 years ago, my dad and I wanted to buy a sailboat. We'd taken some of the courses and we wanted to get into sailing in a bigger way. And then we joined Queen City Yacht Club, QCYC, and my dad was a member there for a year before we bought the boat. And he found this boat sitting there. It had been sitting there in the yard for about 3 or 4 years. It's a 35-foot CNC back from 1974 kind of era. And it was in reasonable shape. The hull was in reasonable shape. The interior needed a bit of work. We did a survey and it said we needed to get most of the electrical redone. Everybody said the Atomic 4 gasoline engine should give us, reasonable service as long as we kind of redid all of the filters and the plugs and learned how to make it work. So that was kind of what we started with. So we launched the boat, put it in the water, and then we started to try and figure out how to get the motor working and the sail up and all of that and the mast up. And so we spent a number, about $700 or $800 initially on a boat mechanic coming in and trying to get the Atomic 4 working. He actually got it working, and then the next day my dad and I tried to make it work. It worked for about 2 minutes and spewed out black smoke and then stopped working, and we tried a few more times, tried to let it clear itself out. A couple other members were pretty keen on the Atomic 4 gasoline engine, which is an old, I guess, tractor motor. Anyway, they say it's pretty easy to keep going once you know what you're doing. So he gave us a few clues. We went down in there and he showed me how to kind of keep the gasoline flowing, so there was gas spurting all over and all over the boat, and I'm like covered in gasoline, and this guy's saying, yeah, this is real easy. Next day we tried to do the same thing, it wouldn't work. And of course I'm thinking this is the same guy who, he gets up on board and he pulls out a cigarette, and I'm thinking the whole thing's gonna blow up. So gasoline engines didn't seem to be working too well, and I work at Bullfrog Power, which is a green electricity company, so I have sort of been thinking about electric cars and electric as maybe an option. So I did some research, went onto the internet and tried to find some example of somebody else who'd done an electric boat as being maybe a simpler, easier way to operate a sailboat. What I love doing is sailing. I love getting out on the water. I love the way it's quiet, and you just get these great views, and you're whistling along in the waves or in the wind, and it's just a beautiful feeling. The gasoline smells and the dirt and the grime from all of that, just trying to get off the dock, was not my favorite part at all. So we started looking, and what I found was there's this company, the best example I could find of an electric boat conversion was this company called Electric Yacht out of Minnesota, and on their website they've got some great kind of profiles of people like myself who were interested, and it actually, made the switch to an electric motor. The best example that I could find kind of close to the model we had was this Cal 40, and it's Royal Langkawi Yacht Club. That's in Malaysia. So this guy had emailed up Bill and said, I want to switch to electric. The diesel engine in my boat's not working here in Malaysia. How can you help me out? So they went back and forth. They paid for the system. And he basically took this old diesel engine. Diesel and gasoline engines are pretty complex things. They're, combustion systems. There's a gasoline engine. There's spark plugs. There's pump electric systems. So there's an electric starter, an electric battery, and so on. So my thought was, wouldn't it be nice if we could, simplify it just have the electric motor, just one simple thing to take care of operating the boat. And so that's what this guy in Malaysia did. He got an electric yacht motor which was able to adjust and go in place of the diesel engine. And he put that in there, and he got 4 deep cycle batteries to power the boat. And he did all of this in Malaysia, which is halfway around the world. So I figured if a guy like that can make a 40-footer like that work halfway around the world, surely here in Toronto we could make an electric motor work. And I will say I did ask around, there didn't seem to be anyone else in the area who's operating an electric boat, except for actually one member at Queen City Yacht Club has been operating an electric boat for a number of years. They've been around for many years actually. In the 60s there was a number of popular electric boats. And going way back to the 1800s, there were electric cars at that time, and there were actually electric boats as well. So electric operating boats is not that new, but what is new is some of the battery technology is evolving so that it's getting a little more reasonable, a little easier to go further distances, less maintenance related to the batteries, which has always been the limiting factor with electric systems. If you have questions as I go along, just go ahead and ask if you like. So this is our boat. We figured out how to get the mast rigged up, and gave up on the Atomic 4 electric motor. We decided on electric yachts. Electric yacht is Scott McMillan's the president. He's an engineer. He figured out how to get all the main components working. And I think some of the key things is that he's got experience, he loves boating, and Minnesota's not actually that far away. He knows about sailing on the lakes and so on, and they've been great to deal with. Email them, phone them, they're great guys to work with. What they offer is basically a full package so that you can basically drop into where your existing gasoline or diesel motor is, and they've got basically 3 different packages. So kind of at the lower end for, up to roughly 30 feet, 8,000 pounds, they've got this 100 IBL model, 3.5 kilowatts, roughly equivalent to 5 horsepower. And then the one we went with is the 180, about a 6.5 kilowatt electric motor. And then if you've got a bigger boat, up to 42 feet, 13.6 kilowatt electric motor. What's more important, I think, is that the motor is a fairly simple thing. Brushless electric motors are pretty common. But what he's also done is the engineering around monitoring the system, so knowing how far you can go. So there's an electronic monitor right in your cockpit, so you know how much electricity you're using, what the amps are, what the RPMs are, and how many more hours you can go at that speed. So you feel like you're comfortable with where you are and how far you can go. With your GPS system, you can know what you need to do to get into shore if there's an emergency and so on. And the whole system comes as a package with pretty good instructions for how to put it all together. So we matched it up, and basically I just emailed them the size of our boat, the weight, and they said, this is kind of the right package to meet your needs. What they can do for you is they can actually plug in kind of the parameters for your boat, tell you roughly what different amounts of electricity you're going to use, what kind of speeds you can get up to based on the different configurations. And I think for me the important one was kind of how far could we go. So it's kind of interesting with an electric boat, if you go roughly at 4.8 knots, depending on the different battery types. So there's 3 kind of battery types: conventional lead acid flooded batteries, AGM, which are absorbed glass mat batteries. That's the kind we went with. They're kind of easy to maintain. They're sealed up. They're not as light as lithium, but they're a lot less expensive. Their number of times you can charge and discharge is pretty good, but not as good as lithium. So if you've got a lot of money and you can afford it, lithium's the best. You can recharge it, up to 3,000 times fully, maybe 500 for AGM and less for typical lead acid. But you can also see with electric, if you're going slow, you can go a lot further. So this is one of the interesting things with batteries and electric. You got to think, about how much battery you need for how far you want to be able to go. If you want to go 25 nautical miles, you got to go at this rate of speed with a certain number of batteries. The more batteries you have, the more it's going to cost. So this is Lorne Spence, who was our electrical guy. He actually is here. We're lucky to have him. He's at the Ray Marine booth. Lorne figured out how to make this whole thing work, working with Scott and Bill. This is Lorne and me in the boat actually pulling the old Atomic 4 out of the hull of the boat. Queen City's got a crane, so we just put the hook in there and we grabbed that old Atomic 4 and hauled it out of there. This is the engine room. You can see it's fairly dirty. That's 30 years of grime and crap that's accumulated there. And then my wonderful wife Lee spent a number of days scrubbing this whole area, and we painted it. You can see the motor mounts here. So the Atomic 4 was sitting there. The electric yacht motor system has pretty good systems, so it was able to just sit right on those same mounts, and you could adjust vertically and horizontally vertically the position to exactly match the old shaft. So here's the old shaft. We did this all entirely while it was in the water, so it's pretty easy to do even though it was still in the water. Lauren and I had a bit of fun with the old clamp that was on there, and so we got basically a prop remover and pulled that old thing off and was basically welded on there. But anyway, it wasn't too bad. This is kind of the package that Electric Yacht sends you. So you've got the electric motor and the mountable mounting system so you can fit it on most boats. The throttle, electronic throttle, some fuses and controllers, and then the cockpit system for telling you how much electricity you're using, how far you can still go, and that sort of thing. So a nice little package, plus an installation manual. And this is actually all of the equipment sitting inside the boat. We've also got 4 Odyssey AGM batteries, the 1800 model. They weigh about 130 pounds each. We got 4 of them for 48 volt system. And they each weigh, did I already say that? 130 pounds, so it's a pretty heavy system. All told though, when you compare the Atomic 4 with a full tank of gas, it's about equivalent, maybe slightly less when you combine the electric motor and the batteries we're replacing it with. So it's about an equivalent replacement, and the positioning of that weight is pretty closely the same position in the boat. So the balance of the boat and the weight in the boat is approximately the same. We do race on Wednesday night. Hey Dale, how you doing? And if I was purely a racer, but I also do cruising, if I was just racing, I might have gone for lighter batteries, maybe lithium. It's a great system for racing. You can head out on the water really quickly and easily, and then with lighter weight lithium batteries and a small electric motor, you'd be all set for a lightweight racing boat. But if you're doing cruising, you need bigger batteries. Here you can see a very important piece of the equipment. This is the analytic charge controller. So one of the things that Lauren did is research kind of the market for the best charge controller for charging the batteries. As you can imagine, with different yacht clubs, with different electrical hookups, different amount of amps available and so on, you want a pretty robust charge controller that can handle different availability of power and so on, and different quality, as well as you want one that can charge the batteries really cleanly and carefully. So the Analytic is a bit of an expensive controller. It's military grade, waterproof, very, very rugged. And that's what we do is when we come into tie up, we basically tie into shore power, and that thing charges up. Most race nights it'll charge in an hour or two because we use so little. But when we were cruising on Lake Ontario, we'd plug it in at each yacht club, and it would take maybe 4 or 6 hours to charge up the batteries because we never really used 100% of the batteries. The other thing you've got is Lauren did all of the cabling, so you've got the proper cabling for the batteries and so on. And here you can see the battery box. Lauren built a really sturdy mahogany box to hold the batteries, and we have a top on that and steel rods clamping those in, so you obviously want to make sure your batteries are really held firmly in place so that when the vibrations and the turning and so on of the boat, you don't want those moving. So those are really solidly planted in there. The batteries are right center in the boat, so whereas the gas tank was off to the left a little, we've centered these batteries so you've got the weight low down in the boat and centered, and then the motor was attached to the prop shaft right here. And here you can see the electric motor now with the adjustable attachments right where the atomic 4 was. It takes up a lot less space, and then this wiring goes up to the batteries and then to the various charge controller and the throttle and so on. And then of course in the cockpit we've got the monitor system, so it tells you how much charge you've got in the battery, how many more hours you can run at that speed, what your RPM is, how many volts you're using, how many amps. So it flips between those things. Real simple, solid state, and waterproof, and sits in your cockpit. And then we replaced the old gasoline throttle with the electric motor throttle in pretty much the exact same place. Lauren built a little box to hold all of the electronics, and that just came up from underneath and gives us forward and reverse, and then a locking key as well, so you can lock up the boat. So this was day 1 of testing, so it took a couple weeks to get everything sorted out, and then we took it out on the water and basically took it up to 5-6 knots on day 1. We tried reverse, forward. It's super simple to operate. You basically push it forward to go forward, back to go back, instant power, no turning any ignitions on. It just works, and you've got all kinds of power when you need it. And we were really thrilled. We were on our way out. You could hear each other talking without any problem. I don't know if you're used to a normal motor, it's quite noisy. Well, here all of a sudden you can hear the birds chirping on the island. You can talk to each other in a normal voice. And it's clean. There's no smell of gasoline or diesel. It was a fabulous experience, and it really kind of matched the kind of sailing experience that I love so much. And so we thought we were on to something really good. So that was our first run. We charged it up. We were ready to go. That's my dad, my partner in all of this, the guy who said, yeah, let's do this. This kind of gives you a rundown. You know, you always want to know what the costs are. Every boat's going to be different. Ours is a 35-foot CNC, so, you know, 1974. We were redoing the wiring anyway, so this doesn't include all of the rewiring. This is specifically replacing the Atomic 4 with the electric system. So basically, from Electric Yacht, we got that electric motor, the monitoring system, the throttle, the switch, the fuse box, and the connector for the prop shaft. Basically a full package of everything we needed except for the batteries and the charge controller. So that's our system. There is a lower end model, the 100 model of the Electric Yacht system is around $3,500 for boats up to roughly 32 feet or so. Then we chose AGM batteries, which are kind of the middle of the road, middle of the cost spectrum. And we went with 4 Odyssey batteries, big 130-pound batteries to get us up to 48 volts, which is required for the system. Obviously, if you're doing mainly racing, you could go with smaller size and obviously less cost as well. If you've got a bigger budget and you want lightweight, lithium can cost 3 or 4 times as much, but you get many more charges. So in the long term, lithium is going to cost you less, because you're able to recycle it, recharge it up to 3,000 times. So over a long period of time, that extra, that 2 or 3 times extra cost actually pays back. But it is a bigger upfront cost. AGM is nice because it's there's nothing to service. It's really easy to maintain and so on. There's the analytic charge controller. So this is a pretty high-end charge controller. There may be less expensive charge control systems, but certainly for quality, for waterproofness, for military grade quality, it's worth the price as well. And then all of the installation, battery cables and so on was roughly an additional $4,000 on top of that for our particular configuration. Obviously, every boat's going to be different, but that gives you a rough idea of what it can cost for a similar sized boat to ours. Any comments on that, Lauren? Or?
Well, in terms of the charge, the battery charge, the reason why we went with the analytic was due to the batteries themselves. When you use AGM batteries, one of the properties of them is that they absorb power very easily. And so if you get a cheaper battery charger, it will charge it for 2 hours and then they'll melt. It can't deliver the power that it needs to deliver for the length of time it needs to deliver it. The analytic charger is designed to deliver 40 amps at 48 volts indefinitely. So that was one of the things that we felt was important. The actual motor itself, you can run it at 48 volts, which is what we did. You can also run them at 72 volts. That ends up giving you about 50% more power than if you run it at 48 volts. One of the issues with that is just has to do with Coast Guard regulations. As soon as you're over 50 volts, you are into what's called ship systems, which is commercial grade equipment. And then you actually need to have the boat inspected by a Coast Guard inspection before it can be certified as seaworthy. So that's, if you are concerned about the amount of power the boat delivers, that's something that's also an option. The one other quick thing is that in terms of the power the motor delivers, people will say 9 horsepower. That's insufficient for a 35-foot boat. The thing you got to keep in mind is that a diesel engine only will produce full power at full RPM. And then it still has to run that power through a gearbox. You can lose 20% of the horsepower the engine delivers in the gearing. With an electric motor, because there's no gearing, you have full torque and full power all the time. So essentially you can say that a 9 horsepower electric motor is equivalent to about a 12 to 15 horse diesel. And a lot of guys will use a 15 horse Volvo or Yanmar in a boat that size comfortably. So, that's something else to think about.
Yeah, Dale?
One question. Did you use this same propeller and stuffing box?
I did. We have stuck with the same stuffing box, and currently the propeller is still the racing propeller that folds back when we're under sail and so on. Doing this for the next season is switching, just for our cruising at least, to a fixed prop. When you switch to fixed prop, the nice thing is when that propeller, when you're sailing around Lake Ontario on a cruise, and it's turning the propeller on a fixed prop, it actually will charge those batteries as you go. So we're going to try that out next year, but we haven't done that yet.
Is the prop different? I understand on torpedo motors they have a special prop. Is a motor for your boat, would it use any different kind of prop if you're to retrofit a non-fold one than you would fit a gas engine?
I don't believe it's a special prop, but certainly we would work with Bill and Scott to size it appropriately for charging as best we can, so that it's not oversized or undersized. But other than that, it's basically a normal prop, fixed prop. Yep.
In terms of if you were to go cruising, can you run the engine like 12 hours a day, or does it get hot and you have to cool it off?
You can run it as long as it has battery. So the limiting factor for cruising is really the battery. And so it depends how much battery power you've got. I don't know if there's any other.
So you can run the electric engine 12 hours?
You can run it full speed. It has a 100% duty cycle. You can run it full speed all the time, no problem.
Then the next question then, how about while you're running it, can you get like a generator to charge up the battery?
Funny, I was just asking Lauren that just before we started, and I don't think anyone that I know of has tried that, but I guess
it's doable.
It's doable. It's possible. Yeah. So yeah, you could have a little, generator, and you could be supplying power and running it. Yep.
Any idea, as you're thinking about going to a fixed prop to get generating capability, and you as cruising, with your current system, the amount of power you have, you can go for so long. Any idea of how long it would take while cruising with this prop to recharge the batteries completely?
It's a good question, but I don't know the answer, and I think there's a lot of variables there. So I think, I don't know, but we're going to find out. So I'll keep you posted. I'll give you my email and the website, and as we do it this coming year, I'll let you know how it goes. But you might be able to talk to Bill or Scott at Electric Yacht, and they might have some clues, some rough ideas maybe. So then on the beautiful thing is, so we bought this a couple of years ago, put the system in, and then basically it took a while. So that first year we basically ran it and put it in store. You know, we only went out sailing for 1 year, and then we put it in storage, and it was kind of neat. So we basically hauled the boat out a couple of years ago. Lauren disconnected the battery connection, and it sat on at QCYC through the winter. There was no draining of the oil, the oil and the gas and all of that. It was just disconnect one thing, and then we reconnected it, plopped it back in the water. AGM batteries came through 100%. There was 100% battery availability. Turned the switch, powered away from the launch with 100% battery after sitting on the dry dock for the entire winter. So the amount of effort to put it on the dry dock, let it sit through the winter, is basically zero effort, and essentially there's zero maintenance. There's been we don't have to get it serviced. We're not putting in spark plugs and air filters and that sort of thing. And then I do work at Bullfrog Power, so we get free power through the the dock power. But I add a little bit of green renewable energy to the electricity cost, and that's about $6 a year for 100% renewable energy from the dock there.
John, one question on that. How long have you estimated that your batteries are going to last? Because that's a fairly expensive thing. So.
Yeah, they are. I think the number I was given was they're rated for 500 charge.
Yeah, the Odyssey batteries are slightly different. You run them to 80% depth of discharge before it's considered to have gone through one cycle. That's different from most flooded batteries, which have a 50% depth of discharge.
Okay.
I don't think John has ever discharged the batteries to 80%.
No.
Now, with charge cycles, they're cumulative. So you can do 5 20% discharges will equal 1 full discharge. The batteries are rated for 500 full discharges before they're classified as being dead.
But
really,
do you lose performance?
There is a slow degradation over time. It is a logarithmic drop-off, though. It's not linear. It'll go and go, kind of slow degradation, and then the wheels will come off at the end. But really, when you think about it, it comes down to use at that point. If you charge them well, they will probably last 5 to 7 years.
So if I could just go by basic number of charges and usage, so you've got full set of batteries, 500 charges times 25 hours of charge. How many hours? That's 2,000. How many hours is that? I didn't do the math.
How many hours of running?
Yeah, how many hours of running?
Well, it depends on how fast you run the boat. The faster you run it, the quicker the batteries discharge. Essentially,
you're using 20 hours there for a complete discharge.
Yeah.
20 or 25 hours of a discharge.
If you go easy on it,
Times
20
500.
hours.
And
Yeah,
the way
10,000 hours.
Yeah, I believe too when we presented last time, the Odyssey rep was there. He did mention something about 8 to 10 years. So I figure, given that he said around 8 years is kind of their max, I figure the way we're using it now, we'll probably make it to about 8 years the way we use the boat. So that's the other thing. I mean, we race every Wednesday night. We do a cruise or two every year for a couple weeks, and I don't see a problem us going 8 years. Now it may go longer, but that's kind of what I'm looking at. Yep.
Oh, and another question on recharging the batteries. So you only have the analytic charger, from what I understand, in your system.
Correct.
You don't have that charger. I'm assuming probably does not charge from solar panels or a wind generator.
No. I have.
Do you know of any options that would basically, top off the batteries and keep them charged up?
Absolutely. I've got 4 solar panels ready to go, and they came off the roof of my house. So there's quite a number of
a roof on your house.
Yeah, I don't need a roof, so I want to charge my boat. So you know, there's many different charge controllers for solar panels, and you can do it in you can do each battery could have its. You know, I have 4 panels. We could tie one to each battery and do each one that way with 4 chargers. Or we could do it, you know, across all 4 batteries. I don't know what I'm going to do, but there's many options. Wind turbine can also be used. And built in is the prop, so the prop will also charge those. But we haven't done that yet, but there's many options. So working with someone like Lauren or an expert at charging batteries is kind of what you got to do. And look at your boat and what kind of panels you're using, what the watts they are, you know, how you want to configure it. But there are many options, and people do it, yeah.
And then how quickly, I mean, I have personally haven't heard, not that I researched, the AGM batteries. I
Yeah.
haven't heard of that technology before. How quickly is the battery technology changing? In 5 years, would it be $500 bucks for a set of $3,000 batteries today?
I personally believe that is a good question. Because electrics are becoming big in the automotive world, it is changing quickly. And that's where, again, right at this moment, my feeling is AGM is the best bet for the next 5 years, 6 years, maybe 7 or 8. But it's reasonable to get your return on investment with AGM. Lithium, you're paying 3 times as much, but that technology is the future. It's going to be evolving very quickly, and I think the prices will be coming down. So I think my personal opinion is AGM's the best bet today, but in 3 to 5 years, I think lithium will be the cost plus technology-wise the best option. So keep an eye on that one. At the moment, it's kind of at the AGM level, in my opinion. I'm going to continue on just to give you, so our first year out, we had just completed all the electrical. We did a trip to Port Credit at the very end of the season. It was getting cold, and it was sort of 8-10 foot waves, and we decided to make a big journey. I'll actually run the video here, but you can kind of see, it's hard to tell in video, but these were big waves. Anyway, we were testing out this electric system. We had a few people on the boat, and we came into Port Credit on about a 6 or 7 foot wave, you know, kind of surfing in on this 35 foot sailboat. And I don't know, you know where Snug Harbor is there? Anyway, there's a pier right here, big concrete pier. We surfed in, and what do you know? It's wavy, and it's a bit of a low tide here. So we got stuck on the sand on our first go into Port Credit with a brand new crew, and me being a fairly new sailor, and a brand new electric motor system and batteries. And all I could think is, my dad's going to kill me. You know, I'm going to ruin the boat on the first big outing. So we're stuck on the sand, and I'm thinking, and somebody else, do we call the Coast Guard? You know, what do we do? Do we keep going? So it's a big sort of moment for testing the electric motor system. So somebody said, maybe we better reverse out of here. And I'm going, oh my God. Like, we're stuck hard with this huge boat, and we're about 10 feet from a concrete wall, and the waves are pushing the tail end of the boat into the concrete pier. So we say, okay, we got to do this. We got to put the boat in full reverse with this brand new electric motor. I put it in full reverse. It starts to do nothing. It just sticks there, and I'm going, we're screwed. You know, this thing is not moving. But the wave did come, like, so it was wavy, so a wave picked it up just a little bit. And that electric motor, you know, was powerful. I mean, it was churning the water, and we slowly started to back up. And as we got a little further back, we were in clear water, and I left it on full for a couple minutes there, and we backed right up out to the entrance to the harbor, and then we again surfed in just to the right to the big harbor marina, the big area there on the other side. And I tell you, I was, you know, adrenaline power there for about 5-10 minutes, but we had run that electric at 100% for 5 minutes, and it all worked great. Horrible thing to try and do on your first thing, but it does prove that in emergency situations it's quite reliable. It worked well, and we then sailed back to Toronto the same day after we kind of came down from that, and we went in. So even though we used a fair bit of power on emergency maneuvers there, We came into Toronto, we still had 68% battery, and we motored quite a ways into Toronto there and had 68% battery. So after a full day of sailing, a lot of extra use, we were still doing pretty well.
One question, did you try a boat going into the waves powering?
Yeah, that was the other thing is, yeah, when we reversed that, we were reversing into these 6-foot waves, maybe 8-foot waves. The way I sometimes tell the story, 10-foot waves. But yeah, that was kind of amazing that it had enough power to get back into those waves, but we also powered into those waves on our way back into Toronto. And I mean, they were big waves, and it had more than enough power. We were able to get up to 3 or 4 knots going directly into the waves with a heavy, heavy wind hitting us in the front there. So even in very tough conditions, we had plenty of power to power into those big waves. The next thing is kind of cruising. So we do Wednesday night racing. Electric motor is fantastic for that. I mean, it's just turn it on, hit the throttle, reverse, we're out, we're into the race course without any problems. It's also just the little secret between racers. Electric motor, there's no way for them to tell that you're actually operating the electric motor. So on those no-wind nights, if you're going a little faster, nobody's ever going to know. I know that because we were coming in under power and the guy was yelling at me, "Hey, you got engine trouble, you got engine trouble, there's no water coming out of the back of your motor." And I said, no, we're electric, so yeah, nobody's ever going to know any difference. Anyways, this year was our first year. We went on a kind of a 2-week cruise around Lake Ontario. This kind of shows the battery monitor. Had a look at it. It shows we're heading out of Bronte in this case. We got about 4 hours of battery at around 4 knots. So there was actually a lot of wind this day, but Lee had kind of hurt herself, so we were just taking it easy. We didn't have a big crew. And we did about 5 knots between Bronte and Oakville, I think it was. Or, sorry, Oakville and Bronte or something like that. But anyway, we did it entirely on electric, charged it up the next day, and it went really well. But this isn't really the big deal. What was the big deal is on the day, so we then, after Bronte, we went to 50 Point. And then we spent a couple nights in 50 Point and charged her up 100%. But on the day we were going to Port Dalhousie, there was 0 wind. So we had to go 15 nautical miles between here and here with 0 wind. So we had to do it essentially all on electric power. And it was an unknown. We've never gone that far before, but in theory we should be fine. So we ran it at around 3 or 4 knots, and we covered this in a few hours. What I also was worried about is when you get to Port Dalhousie, there's a huge current coming down that channel, and I'd read the book, and I've never been there before, but it said it's like 2 or 3, 4 knots, like it's a major current. So I thought, I would hate to be running out of battery power as we're trying to power up that thing. And sure enough, when we got there, it's a serious current. In any case, we did the full cruise under 100% electric power. We got there, we still had about 56% battery power left. So I was actually pretty confident that that was a good sign, that we had plenty of power to get up the channel. We put it on pretty heavy, got it up to 3 or 4 knots, going against 3 or 4 knots, so 6 knots of power going up the channel. And again, we docked and we basically had 50% battery left. So looking at that number of 20% depth of discharge that the AGM could go, we still could have gone a fair distance further. We could have gone another, 5, 10 nautical miles if we had to, something like that at 3 or 4 knots. But I think you always want to keep some reserve. You want to make sure if you get in an emergency situation, you want to have 50% of your battery remaining. And so I think in general, for the kind of cruising that Lee and I plan to do around the coastline of Lake Ontario, the battery system that we picked seems really good. So yeah, I did mention that these are the actual panels. I've got 4 of these panels. I've actually put on brand new panels on the house. I've got 5.6 kilowatts of new solar panels on our house. Great idea. I'm earning about $1,000 a month in the summer, so go solar on your house. But I've taken these old panels and I've got them in our storage locker at QCYC, and I'm trying to figure out the best way to mount those panels on our sailboat to figure out how we can keep it charging, when we're at anchor and things like that. There's a number of options. I haven't figured it out yet, but we'll sort something out and we'll get those solar panel charging. We also have a wind turbine on our property, a 1 kilowatt wind turbine, but you can get these 300 watt wind turbines for sailboats, and that's another option for charging the batteries when you're at anchor or when you're sailing as well. So those things can be combined to charge the batteries while you're sailing. Possibly a generator is also an option for longer distance type stuff. That's basically it. There's sort of information, their website for electric yacht is here, and certainly mention my name, John Wilson, and they know Lauren as well, but they're great. You can go back and forth on phone and email. They'll tell you everything you need to know. Lauren is at the Ray Marine booth. He did all of the electrical work on our boat. Andrew McDonald is a local dealer for electric yacht list, so that for updates for our cruises next year, I'll let you know how it operates and how it works with solar panels and all that sort of thing. So just send me an email and I'll put you on our list and keep you updated. That's what I had to present. Thank you very much, and if there's any questions, just fire away.
For your cruising, when you're underway for hot water, you would always have to be plugged in, right?
We would have to be plugged in, yeah, currently. We don't have like a 12 volt or whatever, yeah. I mean, electric yacht does talk about the ability to, you've got like a lot of battery in a 48 volt or 72 volt system there, and there are ways to plug in inverters to that system to get, you know, more electrical power off the batteries you use for your motor. But my feeling is to keep the two systems separate and just, you know exactly what you've got with your batteries for your motor. But there are different options. Yeah?
Your second last bullet there says
Oh yeah, if you send me an email, I just wrote like all my notes and kind of all the experiences into like a 20-page little PDF file, like a Word document basically. But I'm happy to send that to you. It just sort of tells you the whole sort of spiel I just gave you in an electronic book version. Brief book, short book. Yep.
No, I don't. I work at CNC Electronics. We're the Ray Marine distributors. We also distribute analytic and a number of other products as well. But I still do some work with this sort of thing. Just it's a personal interest to me. So.
So my question then, in terms of if you have a fair amount of electronics on the boat, so if you have autopilot, those kinds of things, that takes up a fair amount of power. Mm-hmm. I'm not sure how much power that, how much that would change your range. Say you went
well, there's an independent 12 volt system on the boat.
Yeah.
Oh, okay.
The way that we had done it was we basically looked at the Odyssey batteries as being a dedicated propulsion power system, and then there's just like a separate two-bank 12-volt system like you have in most boats.
Right,
so
right.
you would power all of your boat electronics, GPS plotter, what have you, off of that.
Completely isolated your
Yeah.
power supposed to completely isolated from all your other electricity.
Exactly.
Yeah.
And it's also for corrosion issues. If you think you get galvanic issues at 12 volts, you kick it up to 48, and it
Right.
accelerates the process. So that keeping it completely isolated that way was also a good idea.
A good
For bonding
electrician, a good boat electrician
Is
is
it?
key.
Yep.
12 volt charge system, right?
For the
No.
house battery, it is.
Yeah, for the
For the propulsion system, it's 48 volt.
Charging.
yeah, the charge is actually up to about 58 volts.